So here we've got a situation of a lion chasing a zebra. The lion is chasing the zebra, and the zebra notices the lion when the lion is 40 meters away. And from this time, the lion approaches with a speed of 15e to the minus something, which is I've just drawn over here, rewritten it, and the zebra runs away with another speed, which I've just put down below over here. Now, to show that the lion's speed decreases over time, whereas the zebra's speed increases over time, we can just draw the graph of both of these functions. To do that, we can just use Desmos or the calculator. But I want to go through those two functions here and see if we can actually recognize the general functions from which they come from. So the lion's general function would be something where it comes from e to the minus x, whereas the zebra's function is something which comes from general function of minus e to the minus x. And yes, there is a 20 in front of it, so I'll talk about that 20 afterwards. So could I remind you that the e to the x function always went this way, and the e to the minus x function was the other way. So that would be e to the minus x. And now the function which is this way is e minus e to the minus x, which is the one that we're looking at, and the last quadrant would be minus e to the x. And the two functions that we are interested is the lion function, which is in yellow, which is going down, and the zebra function, which is obviously going upwards like that. But because it has a 20 in here, so I will just highlight that 20, that means that we're going to raise that red function vertically upwards by 20. And if you draw this out from the calculator or on Desmos, you'll find you'll get an asymptote of 20, and the function for the zebra will be along here. So let's look at the function for the lion. The lion will start when t is 0. The velocity at the origin will be 15. So we'll start with 15. And this is the lion, and this is for the zebra. And our x-axis is the time, whereas our y-axis is the velocity function. So by drawing this graph, we show that the lion's speed decreases over time and that the zebra's speed increases over time. Here I'm looking at the speed of each animal after 1 second. So you can see that the lion has made 13.6 meters per second. And similarly for the zebra, if we insert 1, we'll get 20, take away 20, e to the minus 0.1 times 1, and we'll get 1.9 meters per second. And that is for the zebra. So how do we interpret the answer for this particular integration of V1? This stands for the lion, so we'll just work on the lion here. That's the lion. And we'll take its velocity and integrate it so that will give us the displacement of that lion. So if we do this, 3, 0, this will be 15 divided by minus 0.1, and rewrite the e to the 0.1 t again from 0 to 3. So just substitute 3 and substitute 0, which is minus 150 e to the minus 0.1 times 3, and then we do the same thing for 0, 150 e to the minus 0.1 times 0. And we have minus 150 e to the minus 0.3. Minus and minus becomes a plus, And we know that e to the 0 is going to be just 1, so we will just add 150 to it. And this will be 38.9 meters. So how do we interpret this? The lion has traveled 38.9 meters distance within 3 seconds. In this integral, we can see two functions. One is of the lion and the other one is of the zebra. We can separate them. And this means that we're looking at the distance that the lion travels in the first 3 seconds, which we've already calculated, minus the distance that the zebra travels in the first 3 seconds. So we could write that down again and say that is equal to 38.9 meters minus what the integral of the zebra. So we rewrite the 38.9 and we now find out what was that function for the zebra. So we'll just write it in here, e to the minus 0.1 t dt, and continue working it out. That will be 20 t. Minus and minus makes it a positive 20 over 0.1, and rewrite the minus 0.1 t from 0 to 3. And one more time, now just substituting the 3 and the 0 in here. And I've just been working it out so that we don't waste time. So we'll have 38 is for the lion. That's the distance. And the distance that the zebra has made is here is 8.2 meters. So how does one interpret this? Obviously, the lion's done 38.9 meters, the zebra's done 8.2 meters. If we take away one from the other, we find how much further has the lion traveled. So in the first 3 seconds, the lion traveled more by 30.7 meters. Now, when V1 is equal to V2, that means that the speed of the lion and the speed of the zebra are moving at the same time. And the speed of the lion is decreasing over time, the zebra is increasing over time, so they will be about the closest point at that time. So if we want to find out when that happens, we can equate these. 15 e to the minus 0.1 t is equal to 20 minus 20 e to the minus 0.1 t. Now we can just solve it. 35 e to the minus 0.1 t is equal to 20. That means e to the minus 0.1 t is equal to 20 divided by 35. So we need to find out what e is. So what we'll do is we'll ln this part and we'll ln this part, and ln e now disappears. So what we have is minus 0.1 t is equal to ln 20 over 35. And if we remove the 0.1, we'll have t is equal to minus 1 over 0.1 ln 20 over 35. And we can just work that out on our calculator, because it's very similar to, we can just 1 over 0.1 is 10 ln 20 over 35. In any case, that will work out to be So that will be, time will be the same after 5.6 seconds. So after 5.6 seconds, the lion and the zebra are the closest. But did they actually catch up? Did the lion catch up with the zebra? Well, if we wanted to find out if it did, we would need to calculate both at from 0 to 5.6 seconds of the lion. Where is the lion? And we would also need to calculate at that time where is the zebra at from 0 to 5 seconds, 5.6 seconds for the zebra. And if they are exactly the same, we would know whether they have actually caught up, or we would know how close they are by just calculating the first and the second.